de informática da Itaipu Binacional. Dessa forma, senhoras e senhores, a gente dá por encerrada esta abertura, já chamando a atenção para a nossa grande palestra de abertura, como não poderia faltar. Então, eu gostaria de agradecê-los. Como não poderia faltar, em todos os anos a gente tem sempre o prazer de ouvir um dos grandes entusiastas e também aquele que realmente motivou e integrou o mundo inteiro através do software livre. Falo de John McDougall, e hoje com a palestra online 50 anos de open source e 30 anos do GNU Linux, né? O tema Obrigado por todas as caipirinhas, palestra com John McDougall, o ícone do software livre mundial e muitas décadas de open source e também o GNU Linux. Então vamos agora colocá-lo aqui no nosso telão, é isso aí?
Buenos dias. Can you hear me okay?
Ok. Estamos te ouvindo. Buenos dias. Welcome.
Bom dia also. And good morning. I'm going to arrange my... Okay. My talk today is a talk... Let's see. I have to share my slides. There we go. My talk today is called 50 Years of Open Source and 30 Years of GNU Linux, and thanks for all the caipirinhas. My name is John Mad Dog Hall. I am the board chair of the Linux Professional Institute and the president of Linux International. I would like to dedicate this talk to two people, Alan Turing, who is generally considered to be the father of computer science and artificial intelligence. He is also a war hero who reduced World War II by 2 years and saved an estimated 14 million lives. He is considered to be one of the most brilliant mathematicians of all time. I'd also like to dedicate the talk to Rear Admiral Grace Mary Hopper. She was one of the first modern-day programmers. She programmed ballistics into the Mark I and Mark II computers at Harvard. She wrote one of the first computer programming manuals, and she headed the development of COBOL, one of the first high-level languages. She always thought outside the box, and that's what I would recommend for you also. For those of you who do not know me, I have been in the computer industry for 50 years. I've worked on a wide variety of different architectures and systems, a wide variety of different jobs, a wide variety of different companies from both the very large to the very small. I taught operating system design and database design and compiler design at the university level. But most of all, I like to think of myself as pragmatic, somebody who gets the job done. And therefore, I'm not religious about free and open source software. However, I do think it is the best way of creating software. I'm going to tell you 3 stories that came from my real life. The first one is about Ken Thompson. He is one of the co-founders of Unix in 1969, along with Dennis Ritchie. For years, Ken could just sit down to the console of a Unix system and, with a few keystrokes, log into the computer system as root or super user. People looked for the trapdoor in the operating system sources and couldn't find it. They looked for the trapdoor in the login program, figuring it was there, and they couldn't find it. They looked for the trapdoor in the C compiler sources and couldn't find it. And no one knew how he did it. Years later, Ken told them. The trapdoor was actually in the object code of the C compiler. And every time the C compiler saw that it was compiling itself, it would stick the trapdoor source code into the compiler, compile it, and then erase it from the source code of the compiler. So you could look at the sources until the cows came home and never find them. This was done more than 50 years ago. And the sophistication of people putting malware and things into systems has gotten a lot stronger. I'd also like to talk about a program that happened in Brazil, in Sao Paulo, a program called Hacker Team. Kids were breaking into computer systems, going onto the internet and picking up scripts that could penetrate into people's systems, and then executing them on thousands and thousands of systems until they broke in. Then they would brag about it to their friends, and then their friends would rat on them to the authorities, and they would be found. So a friend of mine at the company for Linux started a program to teach these students how to be better systems administrators, how to have better security, how to be people who could create better systems. And they responded to it. And the program was called Hacker Team. And over the years, thousands of students went through this program and then later on turned to be very successful people in the computer field. I also want to talk about a friend of mine named Nick Walker. I first met Nick when he was 15 years old. He had completed every single course that his high school could teach him. And so, in fact, he dropped out of high school without graduating. At 18, he became a network administrator for a small college, and he saw hackers breaking into the network. So he formed a honeypot and trapped them there. He called the FBI, and the FBI traced them to Italy, and they were arrested. And because of all of this, Business Week magazine put a 2-page article about Nick at the tender age of 19. Nick has gone on to do many good things, including PhD level work at the University of Washington, and yet he has never officially graduated from high school. I'm telling you about these people because all of them did things in effect with free and open source, and all of them became more knowledgeable about the way the software worked by studying that. And so we have to take a look at what the free and open source culture is. We'll start with public domain software, which says that this is where no copyright applies, that the copyright has been given away freely with no restrictions on it, no requests of attribution or anything else. This is actually a very dangerous form of giving away your thoughts and your intellectual property, because it means that people can take it and not pass on that information to other people. They can do anything they want with it. And so I always recommend that you license your software with some type of license. Then, of course, we have closed source software, the same type of software that is done by Microsoft and Adobe and all of the rest of the countries. Originally, before copyright could be applied to software, at least in the United States, software was protected by writing a contract where you would get together with another company and argue for months, and finally you create the contract with the specific price of the software. But then when copyright was applied to the software, people started relying on that to protect their intellectual property and creating licenses of closed source and others. And we'll see more about that later on, as well as these other aspects of free and open source culture. So is free and open source software, hardware, and culture new? No, it is not. The early software was often distributed in source code format because there weren't very many computers of any one type, any one architecture. A lot of them didn't even have an operating system. You wrote your program directly to the hardware. You linked your device drivers into the source code of your program, not the source code of the operating system itself. A lot of times, the early software was compiled and qualified, in other words, tested on site by the people who wrote it. And if you bought a copy of the software, you owned that copy of the software. You could change that copy of the software. It was yours. Later on, you found out that you didn't own the software, you only rented it. And this software, as I said, was protected by copyright law, because a lot of times you might have to pay 100,000 US dollars for a single copy of a compiler to be used on a single machine by one person at a time. And it was worthwhile having that because maybe a computer cost $250,000 to build, and this software would give you 10% better performance if it was a compiler. So that was worthwhile getting that software because, in effect, you saved more than the cost of the software every time you ran your program. A lot of times in these days, hardware was built by wire wrapping wires going from the pins of the chips to other pins. And it was built by hand. So naturally, you could see the way the hardware was built, and naturally, you could see the components that were used in it. So the hardware was, in effect, open source also. In the early 1980s, this began to change because people started to create computer games, computer consoles. Of course, they're a little bit bigger than the ones we have today and a lot simpler. And what would happen is a company would create the board and produce it and start to manufacture it. And their competitors would look at the board, buy one copy, see how it was made, and build the board themselves at a much lower price because they didn't have to pay for the engineering effort of creating the game. Most of the game logic was stored in read-only memory chips, and people would simply copy the read-only memories and create their own games. So the game people went to the U.S. law people and said, hey, we need to protect this. We need to copyright the ones and zeros in the ROMs. And so they did. And later on, those same laws applied back to the source code, which created those ROMs. Eventually, we had to create the end-user license agreement, which meant that if you used the software or if you unwrapped it, you basically were agreeing to all the terms of the contract. But this also meant that you didn't own the code. It was owned by the people who created it. After a while, the universities who were creating software started saying, hey, the software is automatically copyrighted, so we have to have a license so we can even give the software away. Because the universities were not going to be making any money off the software, they didn't want to have to, go through and create a separate license every time they wanted to give their software away. So universities like BSD, the University of California, Berkeley, and MIT, Massachusetts Institute of Technology, started to create examples of licenses that they would embed into the source code to tell people who saw the source code what they could or could not do with those sources and the binaries that were generated from them. And this was followed by many other people creating many other licenses, a lot of times differing only in the names. So they would copy the BSD license and then they would call it the Fred license or the GNU, no, not GNU, but the some other type of license. And this was driving the lawyers of the companies that wanted to use the software crazy, because every time they saw a different license name, they had to stop, they had to read the license, they had to see if it was compatible with the other licenses they had, and this was keeping the use of open software from happening very rapidly. And because of this, we determined the name of open source licenses to allow people to find the licenses that they might be able to use without having to change the name. Now, those were called permissive licenses, and they were permissive licenses because they hardly ever required much out of the people who were copying and using the code. Maybe some attribution, where were you going to do the attribution? Was it going to be in the actual code itself? Was it going to be in the documentation? How much attribution did you have to give? These type of things. But they did not require that the people using that code give the same requirements on to the people who had the binaries. They did not require the people who were using that code to give their changes back to the people who created the original code. And so in the 1980s, there was this project started called GNU. It was started by Richard Stallman of the Free Software Foundation. And he wanted to create an entire operating system that was not only open, but was free. That the changes made to the code would be sent out to the people who got the binaries, and also made available to the people who generated the original code in the first place. And this license became known as the GPL, the General Public License, with another license for libraries and things like that called the Lesser GPL or LGPL. And all of this required that the sources and build information be made available to the people who got the binaries generated from it, but also was made available to people to be reworked back into the original source code so that everybody could use it. And this particular license was called Viral by Microsoft because they said it made it spread to everything, which is not quite true, but probably true enough. Before we leave this area of licensing, I'd like to bring about the concept of dual licensing, or actually multiple licensing. And this is where if one person or one copyright holder has a copyright to all of the software, then that person or copyright holder can actually license it differently to different people according to what they want to do with it. And so, as an example, they might say, okay, if all you want to do is use this for your personal use and you want to be able to, you're not charging any money for it, or maybe you're making money for services outside of that, that you can use the GPL and you need to make your changes available to everybody else. But if you say, well, I don't want to do that, I don't want to make my changes available to anybody else, then you have to come back to me, the copyright holder, and I will write a license that you can use. Maybe it's an MIT license, maybe it's a BSD style license, maybe it's one of the other open source licenses that do not require you to make your changes available to everybody else. And so this allowed people like MySQL or other various projects to be able to license their software freely and to get fixes and changes and things from users via the GPL route, but also to be able to allow people to have a different type of licensing if they want to sell commercial code or make some changes that they want to keep secret to themselves. There's also one more concept, and that is called loosely coupled products. Let's say you take a large series of different pieces of code and you put it in a hardware box to make a solution for somebody. You may take various pieces of different licensed code, like maybe a GNU Linux system as the operating system, but on top of that, you put something like the Oracle database, which is definitely not open source, it's closed source. And you put capable hardware into your box and you make a solution that people can use. Well, these are only loosely coupled items. So nobody expects that Oracle is going to have to give out their source code for their database. And likewise, the GNU Linux operating system is probably something you want to get those changes to because maybe there's going to be some software issues or maybe there's going to be some security issues that you want to fix in your device. And so this is actually kind of the best of all possible worlds of people working together, following the licenses, and generating the products, the solutions that people want to have. And there's much more to this, but we don't have the time to talk about it, so I will continue on. Now, one of the questions that comes up, and one of the things that will be important to this talk, is the question of what is more secure, closed or open source? Now, today, we have a lot of security issues going on. You hear about things like ransomware, of people having their data all corrupted and locked, in order to get money from people. You have pipelines being shut down. You have electric grids being broken into. You have all these really bad people doing these things. And so security has come up in the eyes of people. And people say, well, you can't use free software because everybody can see the trapdoors. Everybody can see the holes. You need to use closed source because you get security through obscurity. In other words, it's secure if people can't see the code and see how to break it. The open source people come back and say, well, wait a minute. We have many people who are looking at the source code for this, and many people can see the issues and break it. And so open source is the most secure thing. And in reality, neither are inherently more secure than the other. If you take closed source code, yes, a lot of times it's produced by what we call professional programmers. These people are paid to do good coding and things, but in reality, it may still be only one person who's looking at the code. And that could still allow a lot of trapdoors and mistakes in programming to get through. But if it's open source, there may still only be one person looking at the code. And maybe they are also very good at programming. But it's in basically the same boat. The real issue is mean time to fix. When the problem is known and when the fix happens, how quickly can you apply that to all the systems that you have? Now, many years ago, I worked on an operating system called Ultrix 32. It was at Digital Equipment Corporation. It was on VAXes. And we had a problem called the Morris worm. It was going around. It was attacking through send mail. And, it was spreading from Unix system to Unix system. And the Unix systems were crashing all over the place. Now, Digital had retired their Ultrix 32 system. They weren't going to make any more fixes to it. They weren't going to do anything like that. They had actually sold off all the rights to the operating system to a small company that did not have the expertise to fix something like this. And I knew that there were still thousands of our customers out there using Ultrix 32 on their older systems, and that their systems were crashing. Now, Digital, of course, had fixed this problem on the systems they were using, which were a more modern Unix system. So I actually had to blackmail my management into creating the fix. And even with that blackmailing, it took over 3 weeks to generate the patch, the binary patch, and send it out to our customers. Now, for 3 weeks, these customers, all they could do is shut off the networking, shut off send mail for their customers. And for 3 weeks, these people had no email going on. Or they had to put all of their systems behind a firewall so the Morris worm could not get through it. In the FOSS community, on the other hand, found out about this problem. They generated a source code fix in 3 hours and put the source code up on the net and said, this is how you fix the problem on all of your systems. And so for 3 years, InfoWeek magazine said that the people who created the best customer support was not Hewlett-Packard or IBM or any of the others, but it was really the open source community. Here's some more modern examples of this: Spectre and Meltdown. We're fairly aware of these type of bugs. They're kind of a hardware issue and had to be fixed inside the kernel. But Microsoft had dropped all support for Windows XP, and there were hundreds of thousands of Windows XP systems out there. So Microsoft was forced by customers to create a patch for Windows XP, even though they had said they were never going to fix that operating system again. But what about all the other security holes that happened in Windows XP and have happened in XP and will happen in XP? I mean, there are people and governments who are still using Windows XP today. And because they can never get the patches and they don't have the source code for it, they're not going to be able to fix those problems. Windows 11 is going to create a lot more problems for people. And Microsoft says, well, if you can't use Windows 11 on your hardware because your hardware doesn't support it, well, then just keep using Windows 10. And the real question is, when does Windows 10 become Windows XP? When does Microsoft drop support for Windows 10 and people have to give up their older hardware and go and use that. And so that's why when you're looking at security, you have to look at your entire hardware and software stack and the combinations of things that go into making that stack. You have to take a look at the applications that work on top of your system. When will people who are making applications stop supporting a Windows 10 application and only do development for Windows 11? This is a problem, and it needs to be addressed, and it needs to be addressed by you. The first and lowest problem, kind of the lowest problem, is something we've known for years called binary blobs. These are binary blobs created by hardware people. They're created by the people that make bootloaders. They're created by people who like graphics cards, where they refuse to give you the source code for the hardware, and they refuse to tell you how the hardware is actually programmed. So they create a binary blob, which is then linked into the kernel or somewhere hiding in your system. And these binary blobs could contain trapdoors and Trojan horses, whether advertently, that they were put in by the manufacturer, or inadvertently because of bad coding. Now, because these binary blobs are in device drivers or in important parts of the kernel, they typically run in a privileged mode. So it can actually go any place and do anything once they get control. And all of these are horrible things that happen because you don't have the source code to be able to fix them. A fix to this, supposedly, is through boot code, the Unified Extensible Firmware Interface, called UEFI, which replaces the BIOS that we've been using for the last 30 years. And that's a good thing, because the BIOS is running out of capabilities that we really need. And it supports something called Secure Boot, which is actually a good thing because it lets you have control over the applications that you run on your system. However, a part of that, which is not good, is that there's only one US-based vendor who's giving out the certificates for Secure Boot, and therefore all of the real ability to use Secure Boot is being dictated, in effect, by this vendor. So we need to have a way of being able to put our own boot code in there, and there's several different methods, but including open source projects that create bootloaders that you can run on your system, and you have the source code for them, so you can change them if you need to. Let's go down a level even further than the operating system. Let's talk about processors like Intel or AMD. These are known as complicated instruction set computers. They have tiny little instructions called microcode that is executed every time you execute a machine language code. Typically, people think that machine language is the very lowest part, the ones and zeros that make the computer work. But in reality, it is a microcode that makes the computers work. And these are tiny little programs that execute every time you execute a machine language instruction. That's why sometimes a machine language instruction on an Intel system takes 1 or 2 clock cycles. Other times it could take hundreds of clock cycles, and you don't know what it's doing in those hundreds of clock cycles. Now, we have brought about another type of computer, and this is known as RISC, reduced instruction set computers. And reduced instruction set computers have much simpler instructions that typically execute on 1 clock cycle, and therefore they're easier to time and understand what these instructions are doing. So ARM and certain Motorola products are RISC instruction set computers. The PowerPC by IBM is a RISC instruction set computer. There is a new project called RISC-V, which is an openly designed RISC processor. It doesn't require any licensing. The processor instructions are well known, and it's easy to see how the processor is built. And therefore, it's even possible to build your own RISC-V processor. Some people have done this by using emulators. They've done this by using something known as a field programmable gate array, FPGA. And this allows you to actually see how these processors work when you're running your operating system or when you're running your compiler on them. It's interesting that you could actually even build your own opcodes if you want to from the RISC-V technology by just changing some of the bits inside of the operations code for the instruction. This will allow you to create your own unique processor that if you had the source code for your own unique operating system, you could compile it so that it only worked on that one specific processor. This is also more than just the CPU. There are other very intelligent things inside of your system, like the graphical processor unit, or various controllers like the USB or the Ethernet or the SATA controller. All of these are intelligent processors that are typically controlled by some set of instructions being given to them. Many years ago, there was something known as a Win modem. Modems originally were strictly hardware devices. You would give certain commands to them over a serial line, and they would do things for you. But they were expensive to make. And so manufacturers came up with a simpler idea. Only make the hardware absolutely necessary to go in the Win modem, but everything else was controlled through the software, which was controlled by the main CPU itself. So these were a lot simpler, a lot cheaper to make, but it meant that they could only work with a driver that worked on a particular operating system. And so for most Linux and Unix people, these Win modems were useless. Now, a possible replacement for some of these devices, for GPUs, for CPUs, and things like that, are the aforementioned field programmable gate arrays, FPGAs. These are groups of gates, basically integrated circuits, flip-flops, transistors, whatever you want to call them, that can be reprogrammed and reassembled through programming. And you can make different things out of them. You can make a CPU out of them. You can then reprogram them and make a GPU out of them. You can then reprogram them and make some other type of controller out of them. And they are very efficient, maybe not as efficient as an ASIC, but a lot more efficient than other methods of doing the same thing. And this is some area that you might want to study if you're trying to learn more about computers. So as an example, one day I went to one of the professors, Professor Zufo of the University of Sao Paulo, and I was kind of angry about the GPU manufacturers. And I said, for certain projects like embedded systems, you don't need to have a GPU that's a gaming GPU that's very, very fast and efficient and stuff. Usually, all you're doing is a few little things that could actually be done by a FPGA. And Professor Zufo looked at me strangely and said, "You're right." And about 6 months later, 2 of his graduate students had created a virtual GPU that could run all of the OpenGL test suites and all of the codecs that people usually use and do it very efficiently. And all of the code for that, all of the information for that is up on the web in GitHub. The students have moved on, they've gotten jobs, but we want to take the rest of that information, actually put it into an FPGA and put it on a board. You could also, of course, do the same thing with a RISC-V CPU, and people have published their work on the web so that people can see what they've done. And it's relatively efficient. It's relatively fast. Now, Linux always was more secure than, say, MS-DOS or early versions of Windows. That's because it was originally designed to be a time-sharing system. It was not designed to be a single-user system. It can be a single-user system, but it knew that there were going to be other users out there. And then when the internet came along, it knew it had to protect people from people coming across the internet. And so we created more robust file system permissions and ownership permissions than other operating systems had. And it supported networking relatively early in its device. So we've been talking about, security issues and things like that. And I want to say something about encryption. Now, a lot of people, and particularly people in government, think that encryption is bad. That, only bad people use encryption. But in reality, encryption is our friend. Good encryption enables good authentication, which means I need to know who you are. I need to know, if you're my friend or not. After all, nobody knows that you're a dog when you're on the internet. And by using good encryption, I can tell who I'm talking to. So in a few years after 9/11, we had all these people in the United States deciding, well, we have to block encryption. We have to make encryption illegal. And then I would have to sit down and write another 4 or 5 page letter to some politician telling them how wrong they were. And then they would drop their bill and things would go on. And so we have several good encryption techniques that are in free software, so you can see how they work. So, for example, the GPG encryption code that was based off of pretty good privacy earlier. You can see how it works. There is a web of trust set up. And we should go around teaching people how to encrypt and how to authenticate who they're talking to. Even bad encryption is better than no encryption. And as long as you understand the goodness or badness of your encryption that you're using, then that's good encryption. And if people say, well, evil people will be using this or horrible people will be using this, that might be true. But you cannot have morality through technology. We have to then go back to the way we always did things, which is if you think somebody's doing something bad, you go to a court, you get a subpoena, you go a search warrant, and you go to them and you say, you have to de-encrypt this to show us, but we think you're doing something bad. Without good encryption, people can look at what you're doing and you never know it. And that's a problem. So we also need to encrypt our files and our file systems. And Linux gives you many different options for doing this, either encrypting an entire disk or encrypting a particular partition or encrypting it file by file, whichever you want to do. Linux also has something called Plugable authentication modules, which allows authentication of individual users to individual applications. So should you be able to execute that application or not? PAM will allow you to set up the rules to say whether or not you have the right to do that. You can also be using this to allow you to mount or unmount particular file systems when you log in or log out. So if you log out of your system and it's still on the internet and still running, you can dismount the file system that you were looking at. And it's very hard for somebody else to see that file system is there. Now, none of this needs you to modify your application code. All of these things can be done from inside the PAM system itself. There are also some very secure GNU systems. Their security enhanced Linux is SE Linux, which was originally developed by the NSA. And people, the NSA, why should they create a secure system? Surely they know about backdoors and they would leave a backdoor for themselves. And that's wrong, because the NSA needs secure systems too. And if they build a system that was purposely so that they could break in, then it would not be secure enough for them. So the NSA did a good job of developing SE Linux. Red Hat software supports this as a service. There's another method of doing secure systems, and that's called AppArmor. And AppArmor allows you to create secure programs on a case-by-case basis. This is typically used by SUSE or Ubuntu or even Debian 10, where it's actually turned on by default. So now let's say somebody has actually broken into your system. They've gotten in through all these things. They want to try and use your system. Well, one way of doing that is to use tools inside of Linux like changeroot, which will allow you to create like a little jail for them. Let them think they're inside of your system. Let them think they have control of the overall system. But in reality, they're in their own little sandbox. And so they can do all the stuff they want to inside that sandbox, and they can never look out to see the greater environment around them. The same thing can be done with containers and virtual machines and VMware. Another thing you should think about is lightweight directory access protocol to be used in ways of creating security. And you can think about setting up a Linux server using Samba to give better protection to your MS-DOS systems, your Apple systems, and to share files between your systems. All of this code is included with most Linux distributions. And we even have whole distributions which are really oriented towards security, like Unix, which as you use it, as you go out over the web, it hides the IP address of your system, the TCP IP address. It hides it so that people can't see it. And this is actually software that works on Windows and Mac OS and Linux, so you can use the same type of technology on all of your systems. This gives you a lot more protection for people who are looking, scanning the net for IP addresses so they can attack your systems. Cubase OS uses Unix and is Fedora-based and allows you to create a system that is very, very secure. They specialize in security. Tails is a secure distribution of Linux that allows you to put the system on a USB thumb drive, either with or without persistent storage of data, and allow you to take this to various computer systems and plug it in, do your work, store your data, and then pull it out so that you can carry a secure Linux system with you wherever you go. And I have others listed in the resources down below. There are also systems that are very oriented towards creating tools literally to break into systems. Oh, isn't that horrible? These systems are used to break into other systems. That's one way of looking at it. The other way of looking at it is that these tools can be used to test your systems to see if they're vulnerable to other people breaking into them. And so learning how to use distributions like Kali and Parrot Security OS are ways that you can become a better systems administrator or network administrator. I talked about Uber solutions, and this goes to the point that nobody ever buys hardware or software by itself. They buy a solution to a problem. And so when you're considering your problem you're trying to solve, one of the things you should do is configure the minimum amount of software and necessary to do that job. And that's the software that you have running on that system. Less functionality means that there's fewer ways for people to break into your system. More functionality creates more backdoors, more unknown things that people could attack you. This is one reason why bloatware is intolerable. You should only put the things in your systems that you absolutely need. You should not run servers and things like that on your systems that draw attention to your systems. If your systems are invisible, nobody knows how to get to them. IPv6 address is your friend. People say to me, why do you like IPv6 so much? And that's because 32 bits gives you 4 billion addresses to go after. That sounds like a lot, but it's not really. But 64 bits gives you 4 billion times 4 billion. And if you take a look at IPv6, you have 128 bits of address space. Now, 64 bits of that is typically used by your ISP. That would allow ISPs in the world to have 4 billion times 4 billion different systems that they could address. That's a lot. But the other 64 bits, maybe it's only 48 bits, that's kind of okay. But between 48 and 64 bits should be allocated only to you, to the person who has a router or something like that, or to an entity. So that's between 48 bits and 64 bits of address space. And if you took a look at 64 bits of address space and you were to access one IP address every second of every day, 24 hours a day, 365 days a year, you would do it for the next 584 years before you had addressed every single point. And so if what you do is you move your IP addresses around in that 64-bit space, people are not going to be able to find where your systems are. It's going to take too long. So they're going to go on to the next one. They're not going to waste any time with you. Unix is very good about this because it hides your IP addresses, and so people don't know where to look. And inside of that, ports can also be reconfigured to different port addresses. Sometimes you get irritated at that because your IP does, your ISP does this, but it's actually a good thing. And if you move your ports around inside of those address spaces, there's no way that anybody's going to have enough CPU power with enough latency to be able to get to you. And then, if they do get into you, you can set up things like demilitarized zones or honeypots to fool intruders as to thinking they actually got into your system. Here's another issue that's coming about, and Windows 11 is going to make this very visible, that you have to have authentication, which we talked about before. When you log into your system, that's one-factor authentication. You use your username and your password to authenticate your username. Well, passwords are horrible. People don't like them. They don't use them. They don't use good ones. They don't change them enough. And so multi-factor authentication has come up. So maybe you've noticed that sometimes you use some type of system and it says, oh, I'm going to send a message to your cell phone and you have to authenticate that it's you. Or I'm trying to change my password. I'm going to send a message to your email system to authenticate that it's you who's doing this. This is multi-factor authentication. And there are keys which are available now that you can plug into your USB port. And when you log in, the key has to be there. Your password has to be correct. That's two-factor authentication. But a lot of laptops also have a webcam. And you could do facial authentication. Now, facial authentication isn't the best in the world, but it's another authentication. Another authentication might be a fingerprint reader. I have a fingerprint reader on my laptop and it works just fine. So that's another type of authentication. Where is my laptop physically? If it's in my home, that's another type of authentication. Now, obviously, I want to move my laptop from place to place. So when it's outside my home, that particular authentication might fail, but all of the other ones work. So I'm still pretty safe. Maybe somebody sticks a picture up in front of my webcam and fools it into thinking it's me, but my fingerprint is still there. So it's all these different levels of authentication. And Linux and free software and open source systems give you the chance to fix all of these, to say which ones you want to use. This particular key is an open source key. This company called SoloKey actually allows you to look at the code that they're putting into the firmware, change the code, putting it into the firmware. The code that goes on your system to do the authentication can be seen, reviewed, changed. And they even have a system called Tussed, which they publish the code for, which gives a time-based one-time use password so that you can have better control over the other systems which you're talking to. Another great free project and security-based project is called FreedomBox. This was started by a friend of mine named Eben Moglin. He is a law professor and a lawyer in Columbia University. He happened to write GPL version 3, the first version of that. He's very concerned about security and privacy. So he started this project about 10 years ago, 11 years ago, called FreedomBox. And FreedomBox allows you to create a server, a very low-cost server running on some single-board computers, maybe using a 2.5-inch hard disk drive you have laying around your house or left over for some project, to be able to have a really secure server and relatively easy to set up. It might not be in the mom and pop area now, but I'm sure that many of the people coming to Latinoware would be able to set this up with no problem. It's built up and included in Debian 11. So if you have Debian 11 running on your system, you can use the code from FreedomBox to set up a very secure system. You can also create a little NAS server off of it using things like Samba. And so you can have a very secure system for all the systems in your house and, run them off of this little CPU here. This is all the different functionality that's normally included inside of FreedomBox. And they have a nice dashboard, which makes it easy to set up each one. It explains to you what it is. The documentation is very, very good. And you can set up a very secure system by it. On top of that, you can have federated social media. You may have heard of things like Diaspora or Mastodon or GNU Social. These are all things that could replace things like Facebook and storage drives where owned by companies, which, by the way, are controlled outside of most of your countries. These companies like Facebook, like all the different cloud companies, have headquarters inside of the United States. They are under the laws of the United States. They are under the rules of the United States. And that means that you have two different sets of laws to worry about: the laws of your country and the laws of the United States. So if you have the server inside of your house and your data doesn't have to go outside of your country, this is much better actually for you and actually for your country. And that brings us to things like gateways. So Linux and Unix systems have traditionally been used to set up firewalls, which can do packet filtering of seeing the packets go back and forth. You can control where the packets are going. You can control what packets go outside of your system and where they go. And you can set up demilitarized zones for things you really don't care about. If you want to execute things and you don't care about where the data is going and stuff, you could have them outside in a demilitarized zone instead of the protected zone inside of your systems. You can also set up virtual private networks so that you can, be sure that your data is going from where you think it's going to where you want it to go. And you can set up secure DNS servers to actually make sure that you are getting the right naming information from the right server. And of course, there's Tor for exchange of files and things like that in a secure way. All of this can be done and get the training for this because it's all on the internet. And we need to train network users and users in particular in how to do the security necessary for them. In dealing with security, certification is actually a very good thing because you want to make sure that the people responsible for your network and responsible for your security actually know something about it. And so go to some place, and this is a blatant advertisement, I will admit that, lpi.org. You can find our certification for security. It's a level 3 certification. You can see the objectives of that certification, which says, do you know about this? Do you know about this? Do you know about that? And if you can actually look at those objectives and say, yes, 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 I know about those, then you're probably in good shape. But if you look at an objective and say, I really have no idea what they're talking about, that's a bad sign. And you really need to study up on that particular objective and know it. And then later on, if you want to sell your services or prove to somebody that you know what you're talking about, you can get a certification. And LPI, I was told right before this talk that LPI will be giving a 30% discount on their certification vouchers to everybody who attends Latinoware. And that means virtually, I hope, everybody who registers. Okay. So that's all about security of your systems. But there's a different type of security. And if you live outside the United States, or you live outside of China, or you live outside of Europe, you really need to think about this. Because this is the security of a supply chain. Security is just not about the bits that you have on your disk. The question is, who do you trust? And as an example for this, there is a very large company in Redmond, Washington, that has a lot of software, and they set up centers. There's a center that's set up in Brasilia. And they say, oh, if you would like to see the source code that's in your system, you can go to our center. You can't bring in your laptop. You can't bring in your cell phone. You can't bring in pencil and paper, but we will allow you to look over the network and look at the source code in our operating system so you can make sure it's secure. There's no trapdoors built in it. There's no Trojan horses built in it. And people will go there and do that. And for those people, I have a bridge to sell you in New York City or some other place. Because how do you know that it's the source code you're looking at that actually built your system? You don't. And so you can look at that source code until the cows come home. But there's no guarantee that that source code built your operating system or your compilers or your software. And even if you trusted that, who built your computer? Who put the BIOS software into it? Who put the device drivers into it? Who built your CPU? Maybe they put tiny little changes to the microcode in the CPU. And you say, oh, Mad Dog, that could only be done by a very powerful and wealthy country. Okay? And it really doesn't cost that much. It only costs about $4 billion to make a fab plant, or you could actually just rent a fab plant and make those things. So another thing to think about is, where do you stand in the allocation of resources? COVID has done us kind of a favor and made us realize that the chain of resources is very limited. And we see all these resources going, and it's hard to get CPUs these days. It's hard to get electronic components because COVID and shipping and everything else is standing in the way. Well, how does this affect your country? What happens if one of these countries that is a supplier of these devices creates an embargo against you, like the embargo that the United States has had against Cuba for the last 60 years? And while it's true that Cuba can get its CPUs and computers and stuff from Great Britain or France or other countries, the direct line of information is cut off because the United States has had an embargo against Cuba for so long that most of the people in the United States don't even remember what it was for. this could happen to your country. And so the prognosis that I'm going to leave you with, and this is one of the last things I will say, is that in the past, the antagonists were relatively limited, script kiddies, individual people. But today, we're getting very serious people doing this. People that are supported by various countries, creating ransomware, or doing terrorism electronically, or being entrepreneurs that are selling their software created for cracking to other people to allow them to break into your systems. And so this whole thing has stepped up at least 2 levels. And maybe you don't live in the United States, so you might think about the NSA and what can they do and what can they look at. Actually, just the fact I'm talking to people outside of the United States right now, the NSA can look at what I'm doing, at what I'm saying, because I'm talking to somebody that's not a U.S. citizen. The Patriot Act allows them to do that. Or maybe you are inside the United States and there's something known as the FSB, who used to be known as the KGB, from Russia and the Soviet Union. They're pretty sophisticated too, and they can do a lot of things. So the question comes down to, who do you trust? And this is one of the reasons why we started the Caninas Lucas project at the University of Sao Paulo, to be able to eventually design and build an entire system with no binary blobs, with everything being able to be audited by the government or even by individual people. We want the technology to be shared and spread. And the University of Sao Paulo is also a certificate authority that can give certificates to go into this hardware to take the place of that company in Redmond, Washington. So what if you are really paranoid? Well, you could actually create your own instruction set based on the RISC-V architecture and stick it in an FPGA and put it on a board. And then you could build your own operating system specifically for those instructions. And yours would be the only code that could run on that operating system. The game has changed. Computers don't cost millions of dollars anymore. There are single board computers out there with no binary blobs in them already. The Beagle board computers from Texas Instruments Open Group, completely open. They publish all of their manufacturing capabilities, board layouts, everything. A company called Omnimix from Bulgaria has been doing this for over 25 years, and their boards are very good. And there's web-based development tools and systems that you can use, or you can use the code directly on your own systems. We need to make software collaborative, open, and free. All of it. These companies need to change their business plans to be able to make their money off of services, dual licensing, or whatever. But they need to be open and free. These companies can do marketing. It's no longer you have to have very expensive marketing companies to help you out. You can do your marketing through social media. Financing is a little bit more crowded these days with a lot of crowdsourcing, allow you, instead of having to have angel investors that I always call devil investors. But having a prototype of what you're trying to sell through your crowdsourcing is really good, because it gives your crowdsourcers confidence that you're actually going to be able to deliver on what you're saying. You can create the prototype and then 6 months later deliver on your promise. And so I have a final word to the CIOs, CEOs, CTOs, Chief Executive Officers, Chief Information Officers, Chief Technical Officers of companies who ignore a lot of times the security that they need. They think they created what they think is a magic bullet, and they think that's going to be enough, and it's not. No system is completely secure. But what you can do is make yours so secure that people will not bother trying. And then you need to treat your system and network admins as the valuable asset that they are instead of an expense that you have to have. And for you who are thinking about starting a company, think about starting either a single owner business yourself or maybe two people. This has been helped out by the Micro Entrepreneur Act that was started by in the term of President Lula, where either a single person or two people can start up a business in less than a day and less than 50 reais, or to start an employee-owned cooperative where the employees own the business. They share in the profits and they help you make the decisions. That is a very good way over traditional capitalism. So I am not a good predictor of the future. I've made several bad predictions, but I've made some pretty good ones too. And I don't know what the next operating system will be. People keep saying to me, well, is Linux going to go on forever? And I don't know, but I can tell you that the next operating system will probably be Linux compatible, just like Linux was Unix compatible. But things that do worry me are what most people call artificial intelligence, and I consider to be inorganic intelligence. Because I believe, as did Alan Turing, that if the brain is made up of neurons and synapses, and it can be intelligent, then you can make a inorganic brain made up of flip-flops and network connections, and also have it intelligence. And we have to be careful with that, very careful. And quantum computing is a little scary because it can solve in a few seconds what might take 200 years in normal computing. But again, we have to simply be careful. And I'm not paranoid. I really am not, because paranoia is about things that are not true. And most of my conspiracy theories are true. But I am diabetic, and I'm fat, and I'm old, and I've had 3 heart attacks. But I have had my COVID booster. And I encourage all of you to get your vaccine, get vaccinated, wear your mask, be careful. Because you're the ones who are going to have to worry about all of this. I am reaching my end of life. You are just beginning. Closed source is the enemy. I don't hate BSD. I don't hate people who use products that are not open source and free software. But closed source is the enemy because you can't see it, you can't fix it, and you eventually end up with junk in your drawer. But you should also tell other people that they did good when they deserve it. Keep scratching your itch. That's what drives free software. Keep making the changes and the fixes to it that you can make because you have the source code. Guide the meeting from the back of the room. When I'm in the room with Linus Torvalds in a kernel meeting, he sits in the back. He lets other people guide the meeting. And only from time to time does he turn on his microphone, say what he has to say, and turn it off again. That's a very good way of running a meeting. And remember that building the team is at least as important as building your code. Make sure there are people who will take over your code when you disappear. And we're all getting older, at least I am. Become a mentor to a newbie. All of us had to start someplace. I have 3 people that helped me when I first started programming, and I will never forget them. Sorry. And even master plumbers, as they call the people who work on the kernel, need to have apprentices, people to train, people to help them be better than you are. Don't be afraid of that. Don't be afraid of having somebody better than you are, because you are good to begin with to have that attitude. What really keeps me awake at night is bad beer and bad scotch. But the other thing is the Internet of Things and the infrastructure that we have. Internet of Things is going to be very dangerous if it's built not with free software. With that, I will answer some questions in a question and answer session. And I'll leave up this slide of resources for people that want to take a picture of it or can do a screen grab or whatever so that they can have that. And thank you very much. And I'll try and do questions.
Thank you very much, Mad Dog. I do miss you being in stage in the real Latinoware. Not that this is not real, but it's online. I'll just say some things in Portuguese and I'll be back to you with the questions, okay?
It's fine.
Pessoal, muito obrigado por todo mundo que está aqui. Eu tenho algumas perguntas que eu vou fazer para o Mad Dog em inglês, mas tenham certeza que nós vamos estar trabalhando com a organização do Latinoware para o mais rápido possível a gente ter esse vídeo legendado. Nossos voluntários do LPI vão nos ajudar com isso. E quem mais se interessar em trabalhar como voluntário do LPI pode achar essa informação em lpi.org. Lembrando uma das coisas que o Mad Dog falou, o LPI, junto com o Latinoware, nesse ano em que o Linux completa 30 anos, a gente vai dar 30% de desconto para qualquer um que esteja inscrito no Latinoware. Tá? Então, fiquem atentos aí para as informações. Nesse exato instante, o Juan do LPI, junto com o Thales, aí, que está na organização do evento, estão trabalhando para que a gente coloque o link na sala do LPI. Vocês entram na sala do LPI e vocês já vão ter o link onde vocês podem obter o seu cupom de desconto. Agora eu vou voltar para o inglês, então, para passar as perguntas para o Mad Dog. Okay, Mad Dog, I'm ready. I made note of the questions from the audience. And you know that you probably raised an NSA flag as soon as you mentioned Cuba in your talk.
I probably did. Well, that's just too bad.
Well, I'm taking the liberty to ask the first questions to you. 10 years ago, we were all together in Latinoware celebrating the 20th anniversary of Linux. And at that time, we invited all of the women that were speakers to the stage to also celebrate the diversity that Latinoware was promoting at that time. As soon as you begin your talk, you mentioned Rear Admiral Grace Hopper and Alan Turing. I want to ask you how diverse and inclusive the free soft world really is right now, and in your opinion, what can we do to make it better?
Well, first of all, let me give you some background. In the early days of computer science, there were a lot of women who were actually engaged in programming computers because they tended to be mathematicians. And so the mathematicians were necessary to program the computers. They were being programmed to things like ballistics, and there's a war going on. And so the women were all trained in how to do ballistics and things like that. For the people who have seen the movie Hidden Figures, there were a lot of women who were trained in mathematics and stuff that were helping in NASA shoot, missiles and stuff. They were using slide rules and hand calculators and books of tables. Then when I started programming at Aetna Life and Casualty in 1973, about 40% of the people in programming and in management, low-level management, were women. When I taught at Hartford State Technical College in 1977 to 1980, we had a fair number of women. But then over the years, there seemed to be fewer and fewer women coming into that. And I've never heard a really good reason for that. I have heard things like that there was the little boys clubs and stuff. And by the time I got to digital in 1983, there were very few women who were actually programmers. If you're a woman, you went into documentation. And so 99% of the people in documentation were women. There were a couple men. 99% of the people in software engineering were men with a couple women. And again, I don't really understand what happened there. But there has been an interesting theory given that in the early days of personal computers coming out, that parents gave their sons single board computers like the Kim 1 and the Altair and things like that, and they gave their daughters baby dolls and kitchen sets and stuff like that. And so the girls tended to shy away from things that were viewed as boy stuff. That's a shame, because I'm one of those people that believe that we give away more than 50% of our brains when we ignore women in a particular field. So I think one of the good things is there are active organizations that are trying to get more women in. Linux Chicks, I know, is very active in Argentina and some places in Brazil. There are other organizations that try and get, there's Debian Women, okay, to try and get more women into this. So that's a good part. And in addition, there's also LGBTQ groups that are trying to help out, and particularly the trans area, where they're trying to help trans people get jobs in software, doing testing, quality assurance, and things like that. So these are all good things. It's one of the reasons why I keep coming down to Latin America giving talks, because I want to see more people from Latin America be visible and contributing to all these things. We have a very good, strong Debian community inside of Brazil. We have very, relatively good people from other things. Some of the best kernel developers in the early days came out of Brazil, and other countries. And now that we have things like virtual machines and we have things like single board computers, the price of being able to, or the cost of being able to contribute to all these types of developments has dropped like a rock. You don't need to be at a university anymore. You don't need to have a multi-$100,000 computer system anymore to be able to contribute to these systems. And so I keep emphasizing and pushing and things like that to get people interested, and that's good. And of course, I want to see a diversity of people. I want to see women. I want to see people of color. I want to see, people from different countries. So, it's better, but it's still not what it should be. Okay. We shouldn't see any diversity. We shouldn't see, I say diversity, we shouldn't see any skew in diversifiable means across the programming and systems administration and computer space. There's just no reason for it.
It is great that you mentioned that, because as soon as after Latinoware ends, I'll be going to a meeting in Porto Alegre with the Educa Transforma people, which is a project that LPI supports to bring transgender and transvestite people into the ICT market. And this project has a success rate of 85% of getting jobs to these people. So it's really, we should be really worried about inclusion, and I'm happy about the things that you just said. You also mentioned Latin America, and so I am promoting one of the questions that was in the end, but it has to do with what you just talked right now. Why are you so interested in Latin America? And I will add, did Latinoware improved your interest?
Yes. So I should explain that the first time I came to Latin America was in 1994. This is before I became involved with Linux. And it was an organization known as DICAS, the Digital Equipment Corporation User Society. They had a conference in Caracas, Venezuela. And most of the people in the United States, if you say Latin America, they think of maybe the Brazilian rainforest, the Amazon River, if they're lucky to know that the Amazon River is in Latin America. They think of Piranha, they think of Carnival, they think of the soccer, football, right? But they don't even understand that the largest city in the Western Hemisphere is Sao Paulo and Mexico City. They don't think about that. And if they do, they don't think about the fact that there are huge buildings and subways and monorails and all these things. They don't think about that. So when you come to Latin America and you see these things, you're astounded, right? Likewise, when you think of things like favelas, here in the United States, all we think of is crime and drugs and things like that. They don't think of them as simply people who don't have much money, they need a place to live, and they came from the countryside to the city, and they ended up in the favela. They're not stupid. They're not even ignorant. They are hard workers. They keep their favelas really, really clean. And, it is a shame that people are thought of this way. So when I came to Brazil in 1995, I went to the University of Sao Paulo. 100,000 students, 16,000 PhDs. If there's something that you're interested in and you can't find it at the University of Sao Paulo, well then, I don't know what it is. And I said, we need to be able to tap into this. We need to be able to, use this and to get, them involved. And to answer your question about Latinoware, I love Latinoware, and particularly Latinoware in person. I love meeting the students that come there. I love going to the power plant of Itaipu, and I want to personally say right now to thank Itaipu for all of the support and PTI for all of the support that they have given to Latinoware over the years. And I love going to see the falls. People talk about Niagara Falls, and it's a big thing, and Falls de Iguazu is just, makes Niagara Falls pale by comparison. So, that's why I like coming to Brazil, and the warm people and the, and different universities and things like that. Yes, I like them.
Wonderful, Mad Dog. Sorry, I had to shush someone that was coming into the office. It was not for you.
I kind of gathered that.
Well, there's a question here from our own Juan. The question regarding Latin America was from DVD, coming from YouTube. I don't know who DVD is, so if you give your name, I'll introduce you. If not, I'll just say it was from DVD. Our own Juan is asking a quite interesting question. In 1994, you gave Linus Torvalds an Alpha 64 bits machine. This was what probably led Linux to be ported to all sorts of devices, from the things that are in Mars to vacuum cleaners. How did you get to know Linus Torvalds and Linux? Also, have you ever been to Finland with him? Any anecdotes that you can tell us about?
Okay, so the first thing, yes, at the time that I gave Linus the Alpha, and it wasn't me, it was actually Digital Equipment Corporation that gave it to him, but I arranged for it. Linus was only concentrating on Intel processors and Intel architectures like AMD. So he had one source code tree that was for that architecture, and he was working on that. And that, of course, was a 32-bit processor, not a 64-bit processor. And Digital had just come out with its Alpha system, and we were looking for new ways of using it. I, in particular, was looking for a way that we could do research in very large address spaces. And I could go on for hours talking about that type of issue of working with very large address spaces. Okay. So I met Linus because a friend of mine named Kurt Riesler wanted to have this person come from Europe. I didn't know where in Europe. They were coming to DECUS in New Orleans in the United States to talk about something I'd never heard of. And Kurt, we kept trying to get people to contribute money to this, not having much luck. So I went to my management and I said, I don't know who this person is or what he did, but Kurt has sometimes good ideas. I think we should fund this. And so we did. We funded $5,000 for this person to come from Europe to New Orleans to talk about his software. And then Kurt asked me for even more money so we could rent a PC to put this software on. And I got really mad about this because I didn't sell PCs. I sold real computers like VAXs and BIP systems and Alpha systems. But I got him the money. We got the PC. And then I flew down to the conference, and there was Kurt trying to install the software on there, not having very much luck, when this nice young man with sandy brown hair, wire-rimmed glasses, and a lilting European accent came along and said in perfect English, "May I help you?" And Kurt says, "I think you can." And about 10 minutes later, Linux was running on this system, because that person, of course, was Linus Torvalds. Yes, I have been to Helsinki. During the baby naming ceremony of his first child, Patricia, I traveled to Helsinki, Finland. I stayed in Linus and Tuve's apartment, in their apartment house. And we used a sauna there. And I had tried using saunas before in various hotels, and they were boring, quite frankly. You sit in a hot room by yourself, you're sweating, and, it really is boring. And so Linus turned to me and said, "I've reserved the apartment sauna for tonight. Would you like to join me?" And I says, "Well, I don't know." He goes to the refrigerator, he pulls out a 6-pack of beer. And I look at him, and with this questioning look on my face, he says, "You're probably one of those people who think that Finnish people go to a sauna and they go running out into the snow and roll in the snow or jump into the lake." He says, No. He says, "You drink a beer, you go into the sauna, you sweat. You come out, you drink another beer, you go into the sauna and sweat. And when the 6-pack is gone, then the sauna is over." And I said, "Okay, I know it now. I'll go." So that was my first real introduction to Finnish saunas. I've been back to Finland many times. I've actually attended sauna fiestas, which can be mixed sex things. And I'll remind people that the Finnish people believe that saunas you have to have completely naked, because having any clothes on is unsanitary. But it's just a sauna. You don't think about sex. It's not a sexual thing. It's just people having a good time and talking about things and drinking beer and eating food and having a great time.
This is fun. I've been to Finland twice, and they tell you actually a lie. They tell you that they have the summer and the winter in there. They actually have winter with snow and winter without snow. There are some more questions here, Mad Dog. There is one from Hernan that I'll ask together with a question from Corinto once they connect to each other. So the first one is from Hernan. Once upon a time, we thought we could win the desktop space. Now Linux is literally everywhere. There's a big chance if you plug something to the wall or put batteries in it, it runs Linux. You say you saw all of this coming up as long as you started working with Linux. How do you see Linux in 10 more years? What will be the title of your talk in Latinoware 2031? And Corinthos asks, in your opinion, what are the big challenges in the advance of the free software?
Okay. There's a lot of people that say, it is true that Linux is almost every place. If you're looking at an embedded device, there's a good chance that Linux is in there. Why? Because in the year 2000, there was a change in the embedded market. People had been using proprietary systems in the embedded hardware, used in things like industrial control, used in things like, but then all of a sudden, the internet happened. And when the internet happened, there were two things that became very critical. Number one, you had to have a good TCP/IP stack. You couldn't have just, any type of networking controlling your devices. You needed TCP/IP, and that is not easy to do. So they needed a system to do that. So, actually, three things. The third thing is, when you attach to the internet, you have to have good security, because all of a sudden people can now try and break into your system. So that's the second thing. You need good security. The third thing was you had to work on a bunch of different processors. So everything you developed, the security, the operating system, and everything else, all of a sudden your customer wanted it on a different processor that used a different instruction set, had a different architecture. And all these people who made embedded devices were being driven crazy by this. And then all of a sudden they said, oh, there's one operating system that is secure, that has a good TCP/IP stack, and that, works on all these different systems, and that was Linux. Now, it's true that there were BSD systems like NetBSD that were there too. But earlier, they were kind of tied up with the legal issues with AT&T and stuff. So, there were some people that used BSD for their embedded devices, and there were some people that used Linux, depending on their business model. So these are, this happened with embedded systems. With supercomputers, this happened in 1994, 95, because companies like ECL and Cray and a lot of others were going out of business. And so they needed computers to solve these big problems that mostly had to do with fluid dynamics. Fluid dynamics is how heat travels through, and other things, force and other things travel through liquid systems. Well, even solid systems have fluid dynamics because you have heat traveling through metal, you have heat traveling through wood. Those are all fluid transfer of heat through solids, but it's fluid dynamics. Weather is fluid dynamics. Oceans are fluid dynamics. And it's a very CPU intensive process. So these companies that were making supercomputers that were going out of business, and NASA needed something that could do fluid dynamics. And so the two people, Dr. Thomas Sterling and Donald Becker, came up with the concept of Beowulf supercomputers. But they needed an operating system that was free and open, and they looked around and they chose Linux. And so overnight, Linux became the darling of supercomputers. And today, all 500 of the fastest computers in the world run Linux. There used to be two that ran Microsoft, but they gave up because Microsoft couldn't pay them enough to keep them going. So that's supercomputers. Server systems. All of a sudden, the World Wide Web was there, and we needed an operating system to do shell accounts, to run the web servers and stuff like that. And people just naturally went with Linux. And it helped that by this time, Linus Torvalds had made his source code tree support not just two different architectures, Intel and Alpha, but N different architectures. So adding a new architecture was not a big thing for Linux. And so this became just something that was natural. So now you come to the desktop. And why don't more people use Linux on a desktop? And the answer is they are. It's just we don't call it Linux. We call them Chromebooks. We call them netbooks, okay? And, what's behind the Chromebook or the netbook, because they have to be very inexpensive and they have to be relatively lightweight, a lot of times is a Linux system. And so, if you add Chromebooks to all the other systems, you find there's an ever-increasing number of Linux systems out there. And part of this was helped by the fact that in the early 1990s, the emphasis off of the graphical user interface of the operating system shifted over to the graphical user interface of the browser. So no longer could a person just sit down and say, well, I'm logging into MS-DOS. I type in the word, I see the word login. I type in my login name. I type in my password. I get the prompt. I type in this command. They're writing all this stuff down in a paper notebook to tell them how to use their operating system. But now all of a sudden, they're dealing with different scroll bars that look different on different browsers and, all these different applications. So they can't write this stuff down anymore. They actually have to understand, what does a scroll bar do? And generally, what does a scroll bar look like? And so they get used to these different interfaces, and all of a sudden, now they can go over and use Apple because they're not using the notebook to prompt them anymore. I saw this with my own parents. So this is allowing people, just even the general user, to become more used to different operating systems supplying the solution that they want to use. So these are some of the things, and I am hoping that if we tell enough people the real reason why they should be using free software, if we get them to understand that, then we will see even more desktops become Linux-based systems, whether it be GNU Linux or whether it be Chrome Linux, Chrome OS. The real thing, I said before, our enemy is not Chrome OS. Our enemy is closed source code. That's what we have to fight against. And, our enemy is not companies that give value to their software and then want you to pay some type of fee, whether a service or whatever. Our enemy is the fact that they're still using closed source code. And we've got to get them away from that.
There is one question that is still missing from that is, what is going to be the title of your talk in Latinoware 2031?
I am 71 years old. And as I go running through the airports, sometimes it's hard for me to get from one gate of one airport to another. It's harder. That's the bad news. The good news is, because of the pandemic, I realize I have about $2,000 worth of money saved up from canceled airplane flights from 2020 that I have to use before 2022. Or December 31st, 2022. So when Latinoware of 2022 happens, I have some money that I can use to come down there to see Latinoware. But this is part of why I had some of the slides in my talk. I have to realize that we need to bring younger people in. We need to pass the baton to these people, and we need to get them supporting free software into the future. And, so that, I think, is going to be my talk for 2031 Latinoware. That really will be, thank you for all the fish.
That's good. I actually think of you as some sort of Harry Seldon from the Foundation. We will see you in 3D from thousands and thousands of years in the future.
Well, see, there we go back to Alan Turing again. There might be an AI mad dog who will give you, and how do you even know it's not happening now?
Yeah, you're right. DVD's name, the one that asked the question before, his name is David Aragon. So thanks for the question. Okay. Carlos Cartola, I believe Carlos is going to be talking here in Latinoware also. He mentioned that several of these supercomputers that you mentioned, they are actually running Linux here in Brazil.
Well, no, but one of the reasons when I first went to Sao Paulo, when I first went to the University of Sao Paulo, they had the first Beowulf supercomputer that I'd actually seen in real life. I'd read about them, but I saw one in real life at the University of Sao Paulo, and they were doing two things with it. Number one, they were doing real-time Toy Story quality graphics. That you would have a little person, a little image of somebody standing on a spot on a stage, dressed up in a tuxedo. He had a baton in his hand, and actually, you held the baton. He was a singer, and as you move back and forth, he would follow you. The light changes would change. This was all done in real time. The Beowulf system generated the image, the music, and his voice in real time. That was impressive. But something was more impressive. An MRI is basically a photograph of a woman's breast to be used for looking for cancer. And it generates an image that a doctor would look at. But it's very complex. And a lot of times, if a doctor looks at more than 5 or 6 of these a day, they will make mistakes. So the university wrote a program to look at those images for breast cancer that was 95% accurate. It would say if a woman had breast cancer or not, and it would, in those 5% of cases, it would say the doctor has to look at it because there's not enough evidence to say it. But whatever that program said, it was correct 100% of the time. However, it took 20 hours to run this program on a Sun Microsystems workstation. The Beowulf system could do the same project in 10 minutes. And so the woman who had the breast, had the MRI, was still in the hospital, signing her forms for getting out and stuff. When the doctor could come along and say, congratulations, you don't have cancer. I'm sorry, you do. And we have to, schedule your operation. Or I need some more time to look at this, but we still need to schedule this. So how many women's lives were saved by that software? And that was when I started to understand the power of the people in Latin America to solve problems. Most recently, the University of Sao Paulo used a Labrador and a Pulga system created by Quinitas Lucas to create low-cost respirators to go out through Latin America for coronavirus. Normally, a respirator is $20,000 to $30,000 US. Their respirator is about $2,000 US. So you can buy 15 of the respirators that were developed by the University of Sao Paulo, as opposed to one from other places.
Very good, Mad Dog. There are several other questions coming up. Unfortunately, our time is not infinite, so I'll leave the last question as rather than a technical one. I think it's quite of a fun one. It's from Eduardo. Would you rather fly on Elon Musk or Jeff Bezos' rocket to the moon?
I have no desire to go to the moon. I have no desire to ride on their rockets. I am actually more interested in trying to explore the oceans we have and to fix the pollution problems we have and to fix the environmental problems we have than try and reach the moon or Mars or something like that. I am more interested in trying to get nuclear fusion to work, which I think we're much closer at, very much closer due to some recent things. I would like to see that happen, because if we got nuclear fusion to work, and particularly with very small nuclear fusion plants that could be in cities, we could eliminate high tension wires. We would have enough fuel for the next 2,000 years. We could have electric heating in our homes. We could have electric cars. We could have so much stuff. If we put as much effort and money and focus into that as we do in trying to let billionaires go into space, I think we'd be much further ahead. So I'm much more interested in fixing up the planet we have here rather than spreading our stuff out in the other planets.
That's great, Mad Dog. And I thank you for your answer, because mine would be, I just want to travel with Captain James D. Kirk. Well, Thank you very
I would like to travel with Magellan, okay, or somebody like that. I think that would be as equally as interesting and fun. Or Captain Cook, okay.
Thank you very much, Mad Dog. Thank you for being with us here in Latinoware again. I'll switch. I'll ask you to stay here with us because the master of ceremony wants to end the ceremony with us in the stage. But let me switch to Portuguese just a little bit. Só para lembrar vocês, então, que a gente vai estar conversando com o pessoal da organização, a gente vai estar legendando essa palestra do Mad Dog em português e em espanhol também. Na sala do LPI, do Latinoware, já estão lá os links para vocês obterem os cupons e espalhem a notícia, tá? Porque o Latinoware é gratuito, todo mundo que está no Latinoware pode fazer a prova com 30% de desconto e tem 1 ano para fazer. Então, o LPI é a única instituição que tem baixado os preços das certificações, graças ao sucesso das certificações, e a gente tem conseguido preços diferenciados por região. Então, aproveitem, que é uma oportunidade realmente interessante. Com isso, eu vou voltar do inglês, agradecer ao Mad Dog, e esperar a volta, então, aqui do nosso mestre de cerimônias aqui no palco. Gabriel está atento ali. Thales, obrigado aí por nos ajudar com essa questão da organização da sala do LPI. E um agradecimento muito especial ao querido Marcos Ciríaco, que é a alma do Latinoware. Mad Dog, back into English. If you want to say your last words, then the Master of Ceremony will join us.
Okay. So all I want to say is that we are experiencing some very trying times right now with the pandemic, with a lot of issues around government and running governments and economic issues. But I have faith in you, in all of you. And I want to encourage you to get vaccinated, to wear your masks where appropriate, and to love your family and friends. So thank you very much for inviting me to Latinoware, and I'll turn it over to the Master of Ceremonies.